A decision matrix is used in engineering design because it allows for all ideas to be heard. And it is a way of selecting the best idea according to how well it matches up with the requirements. So, here's how it is used. We create a table, just called the matrix, the decision matrix. And I'm just going to go through this together with you for the first one. The first column is going to list the criteria or the requirements of this project. One of the requirements is that it has to improve the average passenger's experience on a plane. Okay, passenger experience. Let's say we have another criteria that requires that it improves the pilot's experience also. Okay, so that, I'm going to write that. Let's say another criteria is that it can be used on all commercial airlines. It has to be used on the commercial airline. And let's say one other criteria could be that it has to incorporate some form of technology, so computer technology. So here we have the list of the criteria and constraints for this project. Now I'm just pretending this, or I'm just making this up for this example here. We have passenger, it has to improve the passenger's experience. It has to improve the pilot's experience. It has to be used on a commercial airline, and it has to use computer technology, some form of computer technology. Those are the requirements. Next thing. The second column you're going to label with importance. And as a team, you are going to decide on a range from 1 to 10, 1 the lowest, 10 the most important, on how important these criteria are while you're making your invention. If your team decides that it has to improve the passenger experience, if you feel like of all these things that is the most important, then you're going to rank it at 10. If you think that's more important than the pilot's experience, that's more important than incorporating technology, that's more important than it being available on all commercial airlines. Let's say the pilot experience, you don't think it's that important, about middle, so you're going to give it a 5, let's say. 5 is about average. Let's say the availability on commercial airlines. Well, since passengers travel on commercial airlines, you think it's important, but not as important as directly affecting the experience of the passenger. So let's say you give it a 7. Now, computer technology, you don't think that's the most important thing. In fact, that's probably the least important of the list. Okay, for you, for your team. So your team decides. Let's give it a 1 then. So now we have the importance ranking 1 to 10 for each of these criteria. The next columns are going to be your team members. So if you have only 4 team members, then you'd have 4 columns for the next section. Okay, I'm going to look at the team member number 1. I'm going to look at their design. What is their plan for their invention? So by this time, when you get to the decision matrix, everybody has an idea. Everybody has their own plan. Okay? Team member number 1, we look at their idea. And let's say it's very passenger friendly. The passengers will love it. It's like the best thing for passengers ever on an airplane. All right, for this section, we're going to rank, again, numbers. For the team members, we're going to rank their ideas 1 to 5. If everybody in the team agrees that team member number 1's idea is very customer friendly, customers will love it, you rank it a 5. So we're going to put a 5 here under team member 1. And then what I'm going to do is multiply 10 times 5. So they get a 50 for that particular requirement on their design. Okay, now I look at the one team, I pick one member at a time. So same team member number one, their idea has nothing to do with the pilot's experience though. It's not gonna help the pilot at all. It has nothing, it's just customer. So we're gonna give it a 1. 1 times 5, 5. Okay, let's say it is available though on every commercial airline. So 5 times 7, 35. It does incorporate technology. It's just based on technology. It's what it is. So that's going to be a 5. 5 times 1, 5. So now we have 4 numbers. We're going to add these numbers up. 95 is the total for team member 1. So the first team member, their total score for their idea is a 95. Now I'm going to do that for the other team members. And whoever has the highest number down here is the winner. In other words, that's the person's idea you're going to use. Okay, but this decision matrix allows really all voices to be heard, and it forces the team to select the design that really best meets the requirements. You don't want just the person who has the loudest mouth. You don't want their idea to always win because their idea might not match the requirements as well as somebody who doesn't have such a loud mouth. Engineering design process, you first stated the problem, identified the need, identified the customer. You then set up your requirements or figured out what do you need? What are the goals? And the constraints, what are the limitations? Time and money are big limitations in life. The challenge in life is to find a balance between time and money. So it seems like people that have a lot of time, they might not have a job, so they don't have any money. Or people that have a lot of money, sometimes they don't have enough time because they're working all the time. Number 1, state the problem, identify the need, identify the customer. 2, list the criteria and constraints. 3, research. 4, brainstorm ideas. 5, come up with a decision, or come up with one idea. Select a possible solution to your problem. Go with it. This is our plan. Is this good or not? Do we go ahead with it? Do we start over? You don't want to start building the prototype if you have no plan. Okay, so in the plan, you're going to explain how you're going to make this thing. So describe a complete description of your solution, of your design. For this challenge, the cost was not important. I told you unlimited funds. But normally, you would still want to put how much it's going to cost, how much time it will take, right? Okay, so that's the design proposal. Now, once we have this proposal, we present it to whoever has hired us. So if we've been hired by these airlines, JetBlue, American Airlines, or if we've been hired by the government, Federal Aviation Administration, we have to find out, is this okay with you? Like, we don't just start building unless we get approval. So let's say it's approved. Once it's approved, we want to make a prototype. So we want to make a 3-dimensional model of this thing. Prototypes are very important. Very important. This is the model really for your invention. This shows us visually how it's going to work. Usually it's a smaller scaled version of the invention. So if you were to develop like a roller coaster, if your plan is you got hired by Six Flags, you have to make a roller coaster, your prototype would be a very small scale model of the roller coaster. You wouldn't go out and start building a model size of a normal roller coaster. It would be a waste of a lot of time and money to do that. It might not even work. The prototype is a model of your idea. So 3-dimensional. We're going to do 3-dimensional here. After we make the prototype, we have to test the prototype. So that would be the next step. It's very similar to like experimentation in the scientific method. We want to see if this prototype works. So if you make a model roller coaster, we got to test to see if it works. If the model doesn't work, the real one is probably not going to work if it's based on the model. If it works and we've tested over and over, we might have to make a little larger model. And in that one, maybe use the materials that we would actually use in the real version. So a little more accurate model of it. If it doesn't work at all, we might have to start back from the beginning. The next thing, though, is going to be, number 9 is going to be make changes, revise, edit with your prototype, or just go back and start over, whatever you have to do. Once you've tested it, and let's say you've made the changes and now it works, the last thing is develop your final product. So now we have our final product. Part of this process is once you have the final product, you want to communicate your results. How are we going to know about this product? I mean, just think about it from a business standpoint. If you make a new airplane that's going to maybe be better than any other airline that's present, like JetBlue, Southwest, American Airlines, whatever, how are people going to know yours even exists? So this is where marketing comes in. Marketing is like promoting your product or service. And now with social media and everybody online, that's one of the biggest ways to market and promote, communicate your results. Also in science, it's not just social media, but we can publish, we can do research and publish articles about our research or our engineering design in scientific journals. And real science, hard science, has to be peer reviewed. In other words, other scientists have to review it and approve that it is science. And it's not just pseudoscience, which is like false science, that it's not just made up. So science, real science, looking at research that scientists have done, any of that, all of that research, if it's legitimate, if it's true scientific research, it has been peer reviewed. So that means other scientists have agreed that it is legitimate. It's not just one scientist putting out a website and telling the world about the best airplane ever invented. Okay, to him it might be the best because he invented it. He might have some loyal customers that think it's the best. But how do we show what makes it so good scientifically? How does his outperform or her? How did his or her outperform other airplanes? Where's the science behind it? What science is involved? So in real science, scientists publish their research. That review of your peers is very, very important in science for it to be considered legitimate, real science. For this case, since we're just, I'm kind of giving you just a hypothetical scenario, making up a plane, I just want you to think about how are you going to communicate your new invention. Think of social media sites. Are you going to have a website? How are you going to promote this thing? So that is really all relating to communication. And this is the engineering design process now. This is just a guide that engineers use when they're solving a problem. So they're creating a solution to a problem by using the engineering design process. And you'll be using this to make your plane. Now this plane project the idea came from the paper plane experiment, but you don't have to use the same paper planes. You're going to make an invention that will improve airplane travel. So it can improve something that the pilot experiences, it improve something that the passenger would experience, it can improve the industry of flight. You could focus on one airline and improve that. You could make it real personal and think about problems you had when you were flying in a plane and how could you improve experience that you had so it would help other customers. I just want you to solve a problem using the engineering design process. So you will go through the steps, you will make prototype, right? You're going to go through all the steps with your team, and you're going to post your results in the form of a Shark Tank sales pitch.